This is Mahbub Hassan from UNSW. I have a question for Aerotraj. Yes, thanks for the nice talk. My question is about whether your system is limited to a single pass of the drone. What happens if the drone cannot finish in one go and has to go back for battery recharging? Can it come back and complete the job, and then you can stitch two data sets together?
Okay, thank you. I think that's a great question. Because I just had 8 minutes, I didn't get to describe all the details. But what happens in Aerotraj is, first, because we're given an area of interest, we have a quick reconnaissance flight. In the quick reconnaissance flight, we survey the entire area and find the structure that we want to reconstruct. Once we find the structure that we want to reconstruct, then we have a model collection flight. In the model collection flight, if we find that drift has accumulated, the drone has to fly back to the origin and then start a new flight session. When it starts a new flight session, it actually has to combine the 3D model that it built in the first session with the second session. So it does a stitching operation there. Because we use this stitching operation, in case we are not able to reconstruct an entire building in one flight, we can actually send the drone back to recharge its battery. But for the buildings that we have seen, we've never actually had to do a second flight. But we have that capability. Thank you for the question.
Hello, I'm Chinmay Shinde from University of Connecticut. Nice talks, everybody. Just one question. I have I think the video capturing related thing, both for the LiDAR and other project. Do you want to would you like to share impact of the resolution of details that you observe when you are trying to predict?
Okay. So in terms of LiDAR, resolution does matter a lot. So what we're actually doing is we have a drone that's flying around. We're streaming point clouds from the drone to the cloud service. So the first impact of resolution is, of course, if you want to send uncompressed data, that's not possible given the wireless bandwidths that you have today. The problem with not sending raw point clouds is if you compress point clouds and you use some sort of lossy compression techniques, which you end up having to use anyways, it's a little harder to align the point clouds together. So that's the effect of resolution. If you have higher resolution, it becomes a lot easier to stitch them together and get a better 3D model.
Hello, this is Kevin from École Polytechnique Paris, France. So I have a question for the two first presenters. So actually, how do you handle the cases where your system is misled? For example, what I know is that GPS is like, when GPS is misled, the error can be very high. Like, for example, you said you have 80% accuracy in detecting if you are near to the window. But what happens in the 20 other percent of cases, because the error can be like tens of meters, and since you are doing that reckoning, did you evaluate that? And the same question kind of holds for the second presentation. What happens if one of the location is erroneous? Did you evaluate how the error propagates through the whole network? That was my question. Thanks.
Okay, thank you very much for your questions. So, in our systems, I think the main usage of the window side areas you can as the GPS landmarks is that we only consider that the users who they receive strong signals. So we define the GPS landmarks where the strong signals that can when such mistakes happen, I think that The oral systems. So, mm, so can you repeat it again? Sorry.
So my question was, if I remember well your system, there was one part, one model that needs to identify whether we are near a window, and then take the GPS location in order to reinitialize the error, right? So, and if I remember well, you said that the accuracy of this submodule was 80%. So there is 20% cases where that module is misled. And in that case, how do you handle the error that is introduced by by this misleading data you receive? Do you understand? I mean, if the question is clear enough.
Sorry, I can't understand entirely.
Okay, maybe we discuss about that later.
Okay.
Hi, thank you for a wonderful talk, everybody. I have two questions, one for specific for the dead reckoning underwater and one for the general one. The first question is that actually the dead reckoning based localization is quite old idea I think that it is quite an old idea in the land scenarios, which we can, for example, enhance that by using other sensors such as like BLE, UWB, or even visions. And my question here is that since you tried with dead reckoning underwater with only IMUs, what other sensors can we try to enhance the dead reckoning accuracy underwater? For example, GPS, or I don't think vision will work. And what do you say with other sensor types?
Yeah, thanks for the question. So it's a very nice question. So yeah, the porting of sensors to underwater environments is not as easy as it's expected, because of all the adversity that we need to protect the sensors from. So for instance, in the deployment that we did, you can see that we wrap up the sensors in this acrylic kind of a sphere. And then we protected further as well because of the depth. So at like 28 meters, it's going to implode, So then this EMU sensor that we had of course, accelerometer, gyroscope, and magnetometer. And another sensor that can actually be considered for this is barometer, because as you go down, at the depth, then it's become colder. So then this is one of the sensors that actually could be used. Temperature sensor could be something as well that can be considered for enhancing the measurements. But besides that, other sensors, like for instance, proximity or light or even LIDAR or wireless, they have too limited coverage because they have to penetrate water. So they are not advisable to be used on.
Okay, thank you very much. My second question is for the authors in general. I'm actually a starter of this domain localization, and my very big concern in conducting the research is that how to make or how to build a persuadable ground truth data set when we conduct experiment. For example, the author of the Aero Traj also had a similar question. And my question here is that then, as a starter, I wish if you all guys, I expect you to share, if there is, interesting story about what your personal huddle when you conduct that experiment and build ground truth, and how you overcome the challenges. Thank you very much.
So I think that's a great question. And whenever you're doing any kind of localization work, finding ground truth is always difficult especially when, when you increase the precision, right? If you're doing centimeter level localization, you can't, I mean, the method that you go to is normally GPS, but if you do centimeter level, you can't rely on GPS. So in this paper, that's the problem that we had. Visually, we could look at the 3D models and we said, okay, if we try this technique, visually this 3D model looks better. You can go to simulators. I think things like Carla, which is an autonomous driving simulator, AirSim from Microsoft, that's for drones and autonomous driving. People are starting to accept that those are good simulators, and they reflect the physical phenomena that you would see. But still, it would be better to get actual ground truth, but the thing is, it's not possible, right? So maybe your system is actually pushing the limits. If your system is pushing the limits, it's really hard to find ground truth for that. So for instance, we have another work on cooperative perception and autonomous driving, and we're saying that we guarantee up to 1 to 2 centimeter level localization accuracy, and there's not a system with which we can evaluate against. Right. So the struggle is real.
Hello, I just want to add something. So basically, the ground truth is the most important thing. Otherwise, you cannot know if your system is accurate, right? So for me, actually, I met the same problem. But I think the SLAM is quite good. So they have big community to do that. So for SLAM, they have the real images, like very good algorithm, like monocular camera, stereo camera, LiDAR, radar, and all these things they have verified, right, through the robotics. It's very, actually the best accuracy we can get. So for me, actually, at the first beginning, I used the ruler, right? Just measure the distance, 1 meter, 1 meter. It's so stupid. So then I checked their paper. I found there's one thing called April tag. So it's a QR code, and they have released the algorithm. I can use their algorithm to do some simple SLAM without any prior device, equipment, etc. So this thing actually helped me a lot. So when you do localization, I think it's just a cost version for SLAM, because for SLAM it's much harder. It requires to establish the map and do the navigation at the same time.
Hi, I'm Shenan from Chicago. So I have a question about this, like efficiency of your navigation systems, especially when you are deploying these tracking algorithms on like a smartphone or on different mobile devices. How do you deal with this like efficiency thing? And do you have like a guideline to follow when you are like, for example, deploying like a deep learning model on a smartphone?
Thank you for the question. So I think that's indeed one tricky question that I also was thinking about this. But actually, when I really design the network, usually if you have this end goal in mind, then you will know what are the possible structures now can be deployed on the smart devices, the edge devices or mobile phones. And then starting from there, you build your network on top of this. And that's one thread. And I know another thread is still you build your model by finding the best network first. And then you do pruning and compression to smaller the model size. But on that thread, I think I think both thread works. Depends on which one you think is more efficient exploring strategy to you. Thanks.
Any other questions? So I have one. I'm wondering, so we looked at lots of different sensing modalities. We had GPS with IMUs, we had light, we even had different locations. What do you think maybe the next untapped sensing modality is. What should we think about next beyond the sensing modalities you guys looked at so far?
I can say a little bit on this. I realize I'm kind of a little bit outlier in this. Mostly they are on very large scale localization. I'm on more smaller scale localization and prediction. But one thing I want to add is recently I realized that on those motion trajectory, because our human have those biosignals, and actually all your activities is influenced and reflected by those biosignals. And then actually for the recently released Vision Pro from Apple, they actually added the biosignals into their head motion prediction, and they find that that will actually help to make the prediction better, because some of your biosignals will reflect the trend that you are going to, or the next step you are going to do. But I guess this is more like small scale.
So I think what you're going at is if we understood the geometry, the uniqueness of the user, that would help you in your model.
Exactly, yes. That would be very helpful. In my case, for example, if you know the location, then you can say, for example, your speed limit could possibly be smaller. And in that case, the prediction would be more accurate. So I think all those localization works actually will be good prior knowledge to my prediction.
Okay, I think the data modality fusion is a trend, because I think every signal like acoustic, light, visual, LiDAR, RF radio signals, all these signals are just a reflection of the real world, like a description from different angle. So only one signal cannot do the automated target. So only you have more data, as much as you can do better.
So I also think so that actually there are a lot of sensors in smartphones, and these smartphones are all can be used for in the multimodal systems. So for example, the neighboring one, he proposed a method by the light spectrum. So I think it is a very good idea that our method can also be combined with his systems to make the system more accurate, because the light and the GPS, they are existing infrastructure, and also they can be accessed to the smartphones directly. So not limited by this existing phenomena. So we can only combine we can only utilize the sensors from the smartphones to find more characteristics of the some indoor landmarks. That's all I want to see.
Yeah, okay, thank you. I just want to complement this by saying that, of course, we have sensors for almost everything, and all of those are low-cost sensors, and the drift that those sensors have is quite big. So then I think instead of looking for new modalities, we should focus on fixing the ones that we have. Because, like if we, in our group, we do a lot of repurposing for sensors, and then even for environmental monitoring, at some point, you want to use the measurements, but then you realize the drift is so high that you cannot tell whether the sensor is right or wrong. So then calibration methods and all of these methods to improve further the readings are extremely necessary. For instance, we have also off-the-shelf spectrometers recently that has been released, but those, if you compare with a spectrometer, which is an appliance which is very costly and very big, the data that you're going to get from those are very, very different. Mm-hmm. So then, fixing sensors, perhaps using AI for looking at the calibration and the compensation, I think should be the next step.
Got it. Any final questions? I have one. Okay, so we look out into the future. We see a lot of companies and standards coming forward. So we have ultra wideband coming in. We have BLE 5.2 has a localization packet structure to help out. I hear Wi-Fi is going to have a new protocol that gives you some localization. So we have all these mechanisms, at least for indoor localization. What are the big kind of challenges left, right? Is that we need to figure out phones, which pocket your phone is, do we need millimeter accuracy? What are the challenges for indoor localization or underwater localization?
Well, I can start with the underwater localization, and the first thing I have to say that there is nothing for underwater localization. There is something for the surface that can be used for boats, for buoys, and all this kind of stuff, but nothing underwater. Actually, we don't have infrastructure that can be used underwater because of all of these, extreme conditions and degradation of equipment and all of these things. So then, bringing some kind of infrastructure should be I think, the first step if we want to start exploring there.
I think the biggest challenge is the computation cost. So our method is based on the smartphones, but now the computation speed for smartphones is not enough to support our work, to work on real-time work. So in my method, we will generate a lot of particles when the user firstly appears in a GPS landmark area. So after that, since there are a lot of particles generated, so the also a lot of corresponding passes were generated. So how to reduce the cost, computation cost is the biggest challenge in my work. So I think not only now, but also in the future, that if my work combined with the other sensors, so the computation cost is also the biggest challenge.
Okay, actually, for me, I think the fingerprint collection is the most important thing. So for example, in this room, we have the Wi-Fi, we have the light, we can take the pictures, but still we need the user to do this, to collect the data. So for uncertain scenario, location, we still get nothing. And this just puts the limitation here. So for every, building or scenario, still need to do lots of data collection effort for it. So I think this will just the limitation here. We cannot have a practical system yet. Even though we have so many papers has been published about the localization.
I think we have time for one more comment, or I can wrap it up.
As we all know, since indoor localization has been researched for decades, but there is not still a mature standard for business application. I believe this is mainly because the indoor sense is various and complex. And as the last question, the construction of the database is also a big challenge because the celebration of ground truth and it need labor-intensive set survey. Now there are many crowdsourcing-based methods was proposed to solve this problem, but it is still challenging in practice. So I think the construction of database is still a big challenge in indoor localization.
All right, just before we close the session and thank the authors, I want to just remind everybody of the schedule. So from 5:30 to 6, there is the ISWIC Design Expo, doing a lot of wearables and clothing. Then at 6 o'clock, there's demos on the second floor. There's a poster at 6:30. There's poster sessions and lake-breaking work on the terrace. And at 7 p.m., there is a gadget show. For the poster and demos, there are going to be awards done. The committee members will do best paper, best demo, or best poster, best demo, but there's also a People's Choice Award, so you can vote. They'll have ballots, and you can vote up to 3 best posters, best demos. All right, so with that, let's thank the committee, or the panel. All right, thank you very much.